right, so we've been learning the vocabulary for kinematics and how to describe the motion of objects with language. But what about those diagrams and the algebra? Well, let's in this video, let's take a look at that. Let's get to the good stuff and see if we can do some of that. So let's take a look at this. We've got this would be a good example of a diagram. We've got a cross-country skier that moves from location A to location B to location C and back to location D. Each leg of the back and forth motion takes 1 minute. So the total time is 3 minutes. The unit of length is meters. And it wants us to calculate the average speed in, let's see, this is, what was the unit here? Meters per minute. And the average velocity in meters per minute of the skier during the 3 minutes of recreation. Well, average speed that we've got on this slide is just distance divided by time. So let me make a little bit of room here, and then let's look at this a little bit more closely and see what we can come up with. All right, let's go back and look at the problem again here then. It said we've got a cross-country skier that moves from A all the way to B. So that's, what was that distance covered then? That's 160 meters, and if I draw something besides white, it would work better, wouldn't it? So let's say we move a distance of 160 meters, and then let's go back. We went from B back to C. So we went from B back to C. So let's see how far that is. That's 160 minus 40, so that's 120 meters. All right, and then what did we do there? We went from C to D, didn't we? So we went from 40 to 120, so then we moved an additional 80 meters, didn't we? Ooh, hang on, that wouldn't work too well. So we moved another 80 meters. Let's see, so we total it all up. Let's see, that's 10, 16, that's, so we went a total of 360 meters. All right, well, let's see. Let's do the math. Now that's just kind of my hen scratch in there, something you guys need to understand. That's not really a calculation. That's just helping us get started. So let's see, we need to do speed equals distance divided by time. So our speed then, we went 360 meters. And how long did this take? So it said the total time was 3 minutes. So 360 divided by 3 minutes. And so our speed equals what then? What's 360 divided by 3? So 360 divided by 3, that'd be 120 meters per minute. Well, I'm running off on the edge of my screen now. Let's scoot this over. Don't you wish you could do this on your own paper? So that would be our average speed. Traveled a total distance of 360 meters, took 3 minutes, so the average speed was 120 meters per minute. So great, but what about velocity? Well, I've got that over on this next page. So average velocity, if you remember, is our change in position over time. Excuse me. One of the things I want to point out to you guys, when you all see this symbol, that is the delta, Greek letter delta, a little triangle symbol. And so the little triangle symbol represents the word change. So a way to read this is that the average velocity equals the change in position over time. Now, change in position is also displacement. So another equally correct way to write average velocity is to say it's the displacement over time. Now, change in position, displacement, that's a vector quantity. And so, you know, V here is not too hard to guess, stands for velocity. But this little arrow symbol on top tells us that velocity is a vector quantity, that direction is involved. So this represents the velocity, and so velocity equals, remember the triangle means change, so velocity equals change in displacement divided by time. Now it could be confusing too. Does D stand for distance or displacement? Well, guys, that's something y'all just have to know. If we're talking about velocity, we're talking about displacement. So D stands for displacement. And on the last one, well, we use D for distance. Well, that's because we were talking about speed. We can use D in both places. You just have to know the difference between the two. All right, so just like in the last one, let me make a little space here. Maybe harder to see, but that gives me a little room to work. So our total displacement, well, let's see, we went from A to B, but then we went back to C, we went backwards, so those canceled out. If you think about it, now see, we went this way, and so we went 160 meters, right? But when we went backwards, you know, that distance, what was our displacement? Well, we only went 40 meters. And then when we went from C to D, well, we added again, but what was the total displacement? We started at A, we went to D, right? So we went a total of what? We went 120 meters, right? So let's take a look at this. Let's do the math then. So our formula is velocity equals change in position divided by time. So our velocity was 120 meters of displacement divided by 3 minutes of time. So our velocity here then, 120 divided by 3, is going to be 40. Ooh, I didn't write that very well, did I? It's going to be 40 meters per minute. And if you take a look at this, then what's really relevant here is we had the same motion of the skier, same time, we had the same event, but when we looked at it two different ways. The velocity was 40 meters per minute. The speed was 120 meters per minute. And that illustrates one of the big differences between speed and velocity. Speed takes into consideration the total distance traveled, and velocity just wants to know where'd you start, where'd you finish, what was the displacement. Now, the only thing about this, now this velocity, we said, oh, wait a minute, that was direction. It had we have to include direction. So which way was the displacement? Well, to the left it says here was west, to the right was east, so we had a velocity of 40 meters per minute to the east. Now we have a complete answer because we have both magnitude and direction, and we're done. This is not difficult, pretty exciting stuff. I hope y'all enjoyed it because we're going to do more of it. See you next time.